Evening, everybody. Welcome to the program. My name is Eric Edelman, and I'm going to be your guide for this Prescott Monthly Night Sky March part of the series. During these socially distanced times, we love to have an opportunity still to connect with you and give you tips and tricks for how to view different parts of your night sky, whether you're a beginner, you're just looking to find your first constellations, whether you want to go more into detail, maybe some deep sky objects, and also alongside that, talk and showcase some of the other parts of the local community here. We're going to have contributions, even conversations with some of people from the Highland Center for Natural History, as well as the Arizona Philharmonic. They're going to be playing a part in this show as well. So chock full of stuff that we're going to be doing today, and I really hope you enjoy the experience. So first, well, we got to get done with tradition, our little piece of housekeeping, which is that we only ever want to have our latest monthly night sky show up. So, for example, we don't want someone coming to our channel and seeing the September night sky in March and maybe applying that to what they can expect to see right now. We want to make sure you only have the most up-to-date information available. So if you were wanting to see the February night sky, sorry, you're out of luck. It has just disappeared just right now. And now you have March for about a month until April will replace it next. But you'll have this show for about a month now. Also, I know that there was a lot of hullabaloo over the talk that we had, if you're watching this live, this afternoon, local Prescott time, noon, that we were going into the subject of warp drive technology. If any of you are coming here from that talk, maybe you're not local to the area, I want to say that this night sky talk could potentially apply to you too, even if you're not in Prescott, Arizona. You just have to figure out where you are north or south of the equator, your latitude. If you're close to 34.5 degrees north of the equator, you're going to see relatively the same sky that I will be talking about here today. If you're located over in the South Pole, not going to see very many similarities, but hey, maybe you could learn something, so you might as well just stick around in either case. But all right, so to start off with, let's take a look at our night sky. So what you're seeing is me over in the corner, and then you should be seeing little points of light that are stars. These stars are going to be visible in the southerly direction around 8:30 tonight. So this is your sky tonight. If you are not seeing points of light, now is your time to fix that. Most likely it has to do with the resolution at which you're watching this video. So on YouTube, there are different levels of resolution. You're going to want to change it. If you're not seeing many points of light in that darkness, you want to try and get it up to 720 would be ideal for you. So for example, you should be seeing my mouse moving around, like over in the top right here. I'm showing you Orion's belt. If you're not seeing stars along there, try and up that resolution, and that should help you with that problem. All right, so today we're going to time travel. We're going to go from sunset to sunrise. We're going to see the different parts of the sky at different times of the night. And starting out with will be that sunset. So when the sun has just started to set, so it rises in the east, sets in the west. So over to the west of the sky, we're currently looking south. What is visible for us to see? We actually have a number of points of interest. We have, for one, a pair of planets. So I'm going to bring on their labels on so you can see exactly where they are. We have Mars and Uranus. For those of you that are maybe not expert stargazers, I wouldn't recommend Uranus. You really do sort of need equipment to get a good view of that. But Mars is a great planet for anybody, even those of you that might just be starting out. And Mars is actually in a place that's relatively crowded with good celestial landmarks. And by that I mean there's good constellations, there's good deep sky objects that either you can use them to find Mars or you can use Mars to find them. Hey, either way works. So we have Mars here. I'm circling it with my mouse. And then right next door we have this bright red star. That bright red star is called Aldebaran, and it is the eye of the bull of Taurus. So Mars is right next door to Taurus. If you know where Taurus is, you're going to find Mars, vice versa. And Taurus is well known for not only its bull-like shape, but also for being next door to a great deep sky object that we call the Pleiades, or the Seven Sisters. And this is a star cluster, so a group of stars clustered together in the sky, some of which we can see with just our eyes. Of course, a telescope would make the view more incredible, but this is one of those naked eye star clusters that we can see in our sky. So you can look at the Pleiades next door to Mars, next door to Taurus. We also have the great hero Perseus hanging out nearby the bull. So Perseus is also a constellation. If you're familiar with that one, you could use it to find Mars nearby as well. So there's Mars is right now sandwiched between Taurus and Perseus. Also, in that region of the sky, we don't only have stars, we don't only have deep sky objects, we don't only have constellations, we also, tonight, will have the moon. So the moon is hanging out right below Mars over there in the west. And it's right now, it's getting close to its quarter phase. And so that means it's getting close to the point where we can see it as half full. So if we can see half of the moon from our perspective, and that half is half full, that's where we get the quarter phase from. So it will be in its first quarter on March 21st, so just in a little bit, and then it will be full by the end of the month on the 28th, as when we'll have the full moon. Now, full moons throughout the year, they are named different things based on sort of how we've related to them through the course of the year. On the 28th, we're going to have one that a lot of people can call the worm moon. And the reason why is that this is the moon where the earthworms are starting to emerge in the northern hemisphere. This is when spring is starting to be sprung, where that frosty ground is becoming not so frosty anymore. So we have this full moon at the time that the earthworms are emerging from the soil. Which brings me to the point, yes, the seasons are starting to change. And one of those big, arbiters, or that bringers of change, is something that we call the equinox, which occurs on March 20th of this year. So we're getting very close to the equinox. What is it? Equinox equal night. It's when relatively the day and night, those are similar in length. And why does that happen? Well, I have one of my favorite planetarium visuals to show you to sort of exemplify why that's happening. So we have to face south to see that. So here we are in the southerly direction, and now I'm going to show you something pretty fun. So right here, what you're seeing is the movement of the sun as it appears in our sky over the course of a year. So if you were to go out of your house at, say, noon every day and take a picture of where the sun's position was, it would form this shape that you're seeing here. Over the course of a year. It's something that we call the analemma. And the analemma is showing us that not only does the sun appear to sort of move back and forth a bit, but also it changes in height. So right now we're getting to the point where it's the highest in the sky. That happens in June. We can't really see the month in this point of view. But the June summer solstice, the longest day of the year, is when the sun is highest in the sky. And then the sun heads back down over the course of half a year until we get to December. We get to the December solstice, the shortest day of the year when the sun is lowest in the sky. So then in between that, we have the equinoxes. For example, we're getting close to the March equinox, so here we're hitting it right about here, where it's pretty much halfway in between the highest and lowest in the sky, equal amounts of day and night, equinox. So we have that in March to herald the coming of spring, and then we also have it in September equinox, to bring in fall prior to the winter solstice. So the positions of where the sun appears in our sky have less to do with the sun going in this weird shape, but more as the Earth orbits around the sun. It doesn't always do so directly on the sun's plane, the ecliptic. It gets a little higher and lower, and as it does, our perspective of where the sun is in the sky shifts over the course of the year. And this is that shape, the analemma, that we're seeing. There are some incredible photographers that have made beautiful photographs of this analemma by taking a picture of the sun at the same time every day from the same position, and making this shape in the sky. So that is the analemma. That is telling us that we are getting very close to spring right now. So since we're in spring, I think it's a good idea to start looking at some spring constellations. So we have a few months here that we're going to be covering different parts of spring. So I'm only going to introduce a couple of spring constellations to you today, and then we'll get more in detail about other aspects as the months roll by. So I have reset our view. We're looking once again in the southerly direction around 8:30 tonight. And so to introduce the concept of spring constellations, I want to tell you a little bit about how seasonal constellations work. I know I talk about that a lot. I just want to make sure everybody knows is that if you're looking in the northerly direction, in the northern hemisphere, you're going to see the North Star, the Little Dipper, the Big Dipper, Draco the Dragon, those what we call circumpolar constellations that are sort of circling around that North Star, that northern point. And they're hanging out there all the time. If we look in the southerly direction, we're going to be seeing constellations that change from season to season. And the constellations that we associate with certain seasons are the ones that are rising early in the night and setting late in the night, that they have the most time in your night sky. And so for spring, well, we have a number of good constellations there. And I'm going to actually proceed to take us later in the night. So around 8:30, I'm going to take us about 5 hours later in time travel. So we're in the about 1 in the morning is where we'll be, so that those spring constellations have had a chance to get really high in the sky, really prominent, and we can cover some of those. So here we are around 1:30-ish, and the constellations that we're going to take a look at today have to do with Virgo. Virgo is one of the constellations that covers a lot of real estate across the sky. It's a very big constellation, and it has this really bright star called Spica hanging out here. Spica is a good starting point if you're trying to find Virgo, to first find Spica. And Spica is what we call a spectroscopic binary. So it looks like one point of light, but by looking at the light that comes from us from that point, we can actually understand that it's two separate stars that are actually very close together. So we have Spica here, and then if we head up a little bit in the sky, we're also going to take a look at Boötes the Herder. And so Boötes also has a very bright star called Arcturus. Arcturus is this red star here that I'm circling. And so we have, that's a good place to start when looking for Boötes. So yeah, my advice tends to be for those of you that are beginning on your constellation journey, that you find the brightest star in that constellation and then you map out the rest of the shape from there. But maybe your question might be, hey, there's a bunch of bright stars in the sky. How do I figure out where these are? So I have some tips for you for that. And this is a little hard to do when we don't have the whole planetarium sky above us. We're sort of centered on this rectangle of the sky. But I'm going to try my best to help you visualize this. So right now we're craning our neck a little bit, looking in the southerly direction. We're going to actually crane our neck so high that we're even looking back north from facing south, so we can see the Big Dipper. So the Big Dipper is hanging out there above Boötes in our view. We're seeing that right here. The Big Dipper is so useful. It's really prominent. You can usually find that shape in the sky. It's going to be in your northerly direction, very close to the North Star, this big ladle and handle in the sky. You can actually use it to find the North Star. You can use that ladle, but we're going to be focusing on what the handle can do. The handle can help you find these bright stars, these two bright stars in these two different spring constellations. So we have this arc of this handle, right? If you follow that arc across the sky, you're going to hit the bright star Arcturus. So what you do is you arc to Arcturus, and then even further than that, you continue your journey. So you arc to Arcturus, you continue the arc, and you spike to Spica. So if you follow the trajectory that handle gives you, you can find those two bright stars, those two different spring constellations, and start to, well, figure out where they are in your night sky. So that's a little tip for you. So with these two constellations, there's not only just the stars that connect them, but also if you look deep into them, you can find these deep sky objects, these different objects that are distant within our galaxy or even beyond. And we're going to take a look at a couple of objects that are hanging out in the region of Boötes and Virgo. First starting with that herder Boötes. So Boötes actually doesn't have too many deep sky objects. It's not it's not one of the better known places to look for deep sky objects in the sky, but it does have some very interesting ones. The ones that are there are pretty interesting. For example, there is a globular cluster of stars. Globular cluster, we'll get into what that is, called NGC 5466. So that circle that just appeared next to Boötes is where it's located in the sky. And then I can show you what it actually looks like. So isn't that gorgeous? This is, what it sounds like. This glob of stars clustered together, an incredible, beautiful amount of them. And so this cluster is one of the things that makes it unique is it has what we call a low metallicity to it. Now, when we talk about metallicity, when it comes to astronomy, it's a little different than in other fields. Essentially, metallicity is referring to elements that aren't hydrogen and helium. So anything higher up on the periodic table than that, anything heavier, is going to be considered sort of metal in this case, the astronomer's periodic table. If a star has there's a lot to cover when it comes to metallicity and stars. I'm going to just touch on a couple of things. In general, you can say that when a star has higher metallicity, more of that stuff beyond hydrogen and helium, it tends to come from a younger generation of stars, that they were made more recently, whereas with a lower metallicity, you don't see as much of that hydrogen, helium stuff. They tend to be older stars, the reason being that a lot of stars get their metal-rich objects from stuff that came from the deaths of other stars. So generations of stars help to make higher metallicity stars. That they do that nuclear fusion in their cores and otherwise, and a supernova sends all that metal-rich objects out into the universe that younger stars, as they're forming, can grab onto. So this particular globular cluster that we're seeing here is actually very low in metallicity. So it means it's a very old group of stars. Scientists actually put estimates on this globular cluster being around 13.5 billion years old. Really, 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 really old, right? That's actually similar in age to estimates of how old our Milky Way galaxy is. So the galaxy being the place where we reside within our solar system alongside 100 to 400 billion other stellar systems, depending on who you ask. So it is a very, very old group of stars indeed. All right, so that's a deep sky object that you can find in the Boötes region of the sky. If we're going to head a little lower down to Virgo and see what's going on in this constellation region. One of the things that last weekend we actually did our educational series on galaxies and the shapes of galaxies, and we were able to fly across space to see the Virgo cluster. And we saw that digitally, and here I thought it would be a good opportunity to show you sort of where that's located in your night sky, and also a view of it from a telescope as opposed to digitally flying ourselves there. So this circle is showing you where the Virgo cluster is, and then I can show you what it actually looks like. So that's an absolutely gorgeous view of the Virgo cluster. It is a cluster of galaxies. So we've looked at clusters of stars, right? This is a cluster of galaxies. And there are roughly 1,300, 1,400 estimated galaxies within this cluster, the Virgo cluster, which is the heart of the supercluster, which has a whole bunch of galaxies, including our local group of galaxies connected within it. So this is it's a very big region of space that we have a huge amount of galaxies, 54 million light years away from us. Now, one of the interesting aspects of this is that you don't need too big of a scope to start seeing parts of the Virgo cluster. I've heard estimates about a 6-inch or an 8-inch scope will start to get you to places where you can start to see members of this cluster reasonably. So if you're somebody that's a hobbyist astronomer, hey, this is a place in the sky, maybe you can look and see something that is, hey, very, very far away. One of the biggest galaxies in this cluster is a galaxy that we call M87. So M87 is a gigantic elliptical galaxy. An elliptical galaxy is different from us. We in the Milky Way, we are a spiral structure. So we have the sort of the center crowd, and then sort of these spiral arms that emanate from that center. Whereas here with an elliptical galaxy, you can see that it just has this elliptical-like shape. It's this huge bundle of stars in the order of trillions of stars, where we and our Milky Way have hundreds of billions. So it is definitely a order of magnitude up from what we have in our galaxy. One of the very exciting things about M87 is that's the galaxy that gave us our first direct image of a black hole. You might have heard all about that in 2019, where the Event Horizon Telescope was bringing forth this incredible picture, which in the center you have the black hole, and you have this light surrounding it, circling it. It was made of this center of this galaxy, M87, that was over 50 million light years away from us. They get a picture of this black hole that they were able to create, which has been that first step of imaging these objects, which incredible step forward for science when this occurred. So yes, the Virgo cluster has a lot going on. We could stay on that one all day, but we have more parts of the sky to cover. So we have that cluster of galaxies. We have the Virgo cluster, but it's not the only cluster of galaxies that are in the sky. So we're going to actually head back up close to where the Big Dipper is. So the Big Dipper high up in the sky, to the point that we're tilting our head to sort of look backward, and right nearby the Big Dipper asterism within the constellation of Ursa Major, we have a constellation called Lynx. So that cat, the wild cat Lynx. And Lynx, we can't really see it perfectly in this view, so I'm actually going to rewind time a couple hours so it comes into view. Part of these circumpolar constellations, you can see them sort of circling there. And so yes, here is Lynx. I can actually bring on the art for the constellation. You see that cat hanging out there in the sky. Lynx, also nearby in this constellation, has a group of galaxies. So the Lynx cluster of galaxies, and I can show you what that looks like. So here's a view from a collaboration of a number of different space agencies, as you can see by the credit below, of different galaxies within this cluster. There's one particular point of interest that I want you to take note of. So there's this sort of red line here. You see me circling that here, this red line. And that is actually a big cluster of stars that is being sort of stretched, expanded, shown to us due to gravitational lensing. So these galaxies, these massive pools of gravity, similar to the ways black holes sort of distort light around them, this group of galaxies is sort of shoving the light that's coming from the star cluster behind it to us in a more magnified view. And what is really interesting about this star cluster is it is very far away and very old and very hot. So I want to show you an artist's impression of what scientists have learned about this red arc that we see here. And it's something that we call the Lynx arc. Now just keep in mind, this is an artist's interpretation of what the Lynx arc should be like. But this is one of the most gorgeous images I've seen in a long time. It is a place of star formation, and star formation in the early universe, because the Lynx arc is located roughly 12 billion light years away. And keep in mind that when things are located really, really far away in space, in the universe, in those terms, we have to see them as they were in the past. That the fastest that we know things can travel is at light speed. If something takes light 12 billion years to get from point A to point B, we have to see that thing 12 billion years in the past. And so we are seeing a region of star formation in space, in the universe, that was about a couple billion years after the formation of the universe. And this is something that was really, really hot. So something that you might be familiar with that's similar, a star-forming region, is the Orion Nebula. It's a cloud of gas and dust where stars are being born. This is like that, but a lot harder, a lot more crowded with really hot stars. So if you saw our show, The Tour of the Stars, we were talking a little bit about how the colors of stars can tell you a little bit about their temperature. The bluer stars being the hotter stars. We have some really extreme blue stars concentrated in this star formation region. And it is an incredible part of space that we're seeing because of some tricks of gravity and light. And this artist was able to interpret that into this beautiful image that you're seeing right here. So we have constellations that can spark our imagination. We have these beautiful galaxies that can give us so much information about the universe. And also, we can relate these objects that we see, of course, to what we know of back home. And that's one of the reasons that we call that constellation the Lynx constellation. Sort of has this little curvy shape to it, perhaps reminds us of the cats that they were based upon. And related to the ground, related to back home, well, the Highlands Center for Natural History actually has some Lynx-related content that they wanted to share, that they wanted to show. And so we're going to see that, and afterward I'm going to have a conversation with Sarah Vincent, the education director from the Highlands Center. And beyond that, we're going to continue our journey across the sky, seeing more as we approach dawn and sunrise. So please do enjoy this Highlands Center clip on, well, something a little Lynx related, and you'll see that very soon.
Lynx Creek, named for one of the many southwestern mammals dependent on healthy freshwater systems, the bobcat. For millennia, the ephemeral nature of water in the arid West has dictated where life can survive and flourish. The wild and free creeks and rivers naturally slow and spread, recharging precious groundwater and creating habitat corridors known as riparian areas. But humans have severely altered the flow of fresh water through dams, irrigation channels, ranching, mining, development, and fire suppression. The result? Watersheds that can be unrecognizable from what they once were. In light of historic degradation of riparian areas, do humans have an obligation to assist and direct these ecologically significant areas back to what they once were through the practice of restoration? Imagine what Lynx Creek might have looked like 150 years ago before the first Europeans moved west in their search for gold. Imagine if Sam Miller and his band of prospectors overlooked Lynx Creek and allowed natural cycles of fire, flood, and erosion to persist. What does a healthy and historically accurate riparian area of the Central Highlands look like? Perhaps cottonwoods, 10 feet in diameter, willow stands wisping in the wind. Beavers gather logs and twigs to build their dams. Spaced out conifers allowing sunshine to warm the granite boulders along the creek. Migratory bird songs resting in the air. Cool, deep water teeming with fish. Freshwater ecosystems like Lynx Creek, unaltered, are the most biologically diverse habitats in the entire Southwest. But Sam Miller did establish a mine on Lynx Creek, near the site of the Highland Center for Natural History today. Ranchers and miners of the past, and commercial and housing developments today, have had impacts on the Lynx Creek riparian area. Follow the trails at the Highland Center and you will see dams, irrigation channels, and clear-cut pine forests, evidence of mining and development along Lynx Creek. The result is habitat loss for plants and animals and increased cycles of erosion and unnatural flooding patterns. You will also notice that fire has not touched this area due to a century of fire suppression strategies and current human safety concerns. What if humans let fire run its course? Pine forests would be less dense, allowing for natural meadows and sunny riparian areas along the creek. The reality is, for as long as we're here, we will work hard to prevent a fire moving through this area uncontrolled. The changes of the past and habitat alterations are a done deal. So how can we mimic fire and other natural processes in order to improve the quality of the riparian area? The Highland Center for Natural History and the Prescott National Forest are working together with funds provided by the Yavapai County Resource Advisory Committee to direct restoration efforts on a 5-acre stretch of a Lynx Creek tributary. During your visit, you will experience some of the current strategies implemented. Look closely along this tributary of Lynx Creek. What trees do you see? Ponderosas and junipers? These trees, while both common and ecologically important, are not what we call obligate riparian trees, trees that can only be found near water. These woodland trees, in increased density compared to the past, increase competition for woody riparian species, leading to decreased biodiversity. Additionally, most riparian species are considered pioneer species, meaning they typically establish in areas after a disturbance like fire or flood. For restoration, our goal is to knock down some of the trees in order to mimic natural disturbances, creating openings and reducing competition for riparian woody species, while also creating a window to recruit these pioneer species. Best practices in restoration include using the living and non-living materials you have available to you at the specific location, rather than bringing in materials from other sites. Therefore, another restoration strategy is to use the felled trees to create check dams perpendicular to the flow. By stabilizing these logs, sediment and debris will build up, mimicking natural dams of the past, slowing and spreading the water. This will contribute slightly to raising the water table, create rich sediment for riparian plants to establish while decreasing erosion. Additionally, this strategy will create pooling habitat and microclimates, increasing biodiversity. The next strategy is to plant the area with desired and historically accurate woody and non-woody riparian plants. The best practice is to transplant individual willows and cottonwoods from the surrounding Prescott National Forest land, so as to reduce any risk associated with bringing in invasive species. Similarly, seeds will be scattered for sedges, cattails, and water-loving grasses. These will be harvested from local plants. The most important restoration strategy of them all is monitoring. The natural cycles of creeks and rivers, as well as ecological systems in general, are complex. There are many factors that impact the flow and health of a freshwater ecosystem. The timeline of any given restoration project can only be estimated. The intended and unintended consequences are broad. Therefore, one of the best things we can do is monitor the progression of change over time in order to better inform restoration efforts of the future. At certain locations on the trails, you will encounter photo monitoring stations. We encourage visitors to snap a picture and share it with our research team. This is a simple way for all of us to engage in the monitoring process. In the end, the alterations to the land that humans have made and perpetuated at Lynx Creek and elsewhere may run so deep that restoration efforts will fail or that improvements will take another 100 or thousands of years. However, when we imagine what was and compare to what is, we may feel obligated to attempt riparian restoration anyway. Using current strategies and accepting the risk of failure, we push on, reminding ourselves that every decision we make regarding land use affects our waterways, and hoping that those decisions are in the best interest of riparian health. After all, from the bobcat to us humans, a healthy riparian area means a better life for all residing in the Arizona Central Highlands.
A big thank you to the Highland Center for giving us another local perspective. I love it when we can tie in different parts of our community, whether it's astronomy, natural history, to these shows, so that you, the viewer, can just get as wide of a perspective on what's going on here locally as you possibly can. And alongside that, I get to welcome here to the live part of the program, Sarah Vincent, that voice that you were hearing during the video, to the program, and so we can continue our conversation a little bit further. Welcome, Sarah.
Thanks for having me, Eric.
Oh, sure, of course. I think our conversations are always pretty fun about this stuff. As somebody who's a lot more outdoorsy than me, I really think you bring a good side to this whole thing. We have these shapes in the sky that we base off of animals sometimes. I was as I was sort of coding in this show, you see that the lynx is just sort of this zigzaggy shape on the sky. And I'm wondering if you could give us some more lynx perspective to maybe fill in the dots where the space between the stars might not necessarily do so.
Yeah, absolutely. So the lynx in our Central Highlands region is the bobcat, which gets its name from the bobbed tail. So bobcats have a short little stub of a tail. And the genus is lynx, and then the species is rufus, so it's Lynx rufus. And rufus means reddish brownish, so we recognize them by their reddish brownish color and their little bob tail. And they're really important feline predators in the Central Highlands of Arizona and North America in general. They're obligate carnivores, which means they only eat meat. So unlike the canids of Arizona, they're targeting rodents, rabbits, and eating them pretty much exclusively. And they're also solitary hunters. So unlike, again, the canids, they're out there on their own, stalking and then taking out their prey, as opposed to hunting in packs and running around together. But I think my favorite fact about the bobcat is they are perfect walkers, which what we mean by that is they take their hind legs, and they place their paw exactly where their front paw landed. Oh. So you can know you're looking at bobcat tracks because they'll fall right in line with their front paws.
That seems like it'd be interesting in the snow. And as you're talking about species local to this region, I'm always looking for excuses not to go outside. I'm wondering if I were to so we can run into these creatures. Are they? You're saying they were mainly hunting small game. Would they be of any risk to humans if we were to encounter one on a trail?
As with all wildlife, we encourage folks to give wildlife the space that wildlife needs to explore and do its thing, because any animal can bite. So we do encourage folks to give bobcats their space. However, they are super not a risk. So don't let that prevent you from going outside and enjoying our Central Highlands here. They're very interested in rabbits and mice and not very interested in you.
Oh, okay. Yeah, that's... So don't have to worry about that too much. I should find another excuse then. So speaking of which, I get a lot of questions as the planetarium guru in Prescott of where are good places outdoors to look at stars, to look at the night sky. And so as somebody who huddles in the dome, I don't think as a good a perspective on that as somebody who works with nature. And so I'm wondering if you could tell our viewers where are good places to look at the stars and the objects in the night sky in the maybe the local Prescott area, and also in sort of the Arizona greater region, where are some good geographies that would be really good for stargazers.
That's a great question, and it's an important part of our local natural history is to know where to observe the night sky with the naked eye. And I'll share with you some places that I like to travel and observe the night sky. However, the caveat is don't let travel be what holds you back. You can
Very
step
true.
outside your home at any point, whether you are a seasoned astronomer or whether you don't spend a whole lot of time outside at night, and just look up. So that's my caveat there. If you're looking for a little bit more of an adventure, though, certainly north of us, northern Arizona, the Colorado Plateau, which is known as a high desert ecoregion, it's a little bit high. Well, it's a higher elevation than our southern deserts, but up there, there's not a whole lot of tree cover. So you can see for miles in every direction. One of the greatest resources of Arizona and the West in general is just space. So the ability to look out at the horizon also applies to night sky viewing. Just being able to see those constellations right on the horizon that normally are obstructed by trees or light. And then certainly going south, the Sonoran Desert, there's amongst the saguaros, laying out in the sandy deserts of the south is a really special occasion to look up at the night sky as well. If you're looking for something a little more local, Prescott is blessed with a whole lot of ponderosa pine trees. So what we recommend is going out away from the trees a little bit towards Chino Valley, Skull Valley, towards the grasslands to enjoy some primo sweeping vistas. And certainly the Highland Center, we have very dark skies out there. So come out for a visit for one of our stargazing nights, and we'd love to see you there.
And yeah, it makes sense that as a sort of a natural history conglomerate, that you would be in a place that's good to see nature, including the night sky. I always have to bring up social distancing during these COVID times. Do you have opportunities for people to stargaze in ways that I don't know how you'd sanitize the eyepieces between each one, or do you have special strategies to make sure that everybody's doing okay during those stargazing opportunities?
Yeah, the wonderful thing about naked eye
Oh,
astronomy
yeah.
is we don't have to share lenses. So as of right now, our night hikes are going to be spaced and distanced,
Okay.
and we do run those either on the full moon in order to experience more of like the wildlife or being able to hike without a headlamp. But we also host those on nights where it's a new moon, so that we can really get a good view of the stars. So we have socially distant, outdoor, masked programs going on right now. To learn more, you can visit highlandcenter.org, and I encourage folks to participate in programs, to volunteer, donate, but most importantly, just come out for a visit and enjoy the fresh air.
Yeah, what she said. I think that we have a lot of opportunities to stay safe and really explore nature at the same time. And Sarah has covered a great amount of what you can do here locally. And so thank you for telling us that. And thank you again for being live here and for sharing with us that information about Lynx Creek and all of that. Yeah, really do appreciate it.
Great. Well, thank you so much for having me, Eric.
Enjoy your stargazing tonight.
You as well.
All right, so we're heading back into our night sky view. So we had that great conversation with our Highlands Center rep, Sarah Vincent. We still have more of our night sky to cover. So we got from sunset, we got to see the planets where the moon is, a couple of constellations over there. We headed to the middle of the night to see some spring constellations. And now we're going to head even later into the night to when the sun is starting to rise, because there are some, well, interesting points that we can cover there as well. So remember, things are rising over in the east and they're setting in the west. So we're going to head to the easterly part of our sky and also get down to roughly ground level. We were up really high recently, so we're going back down. And I can also show you the cardinal directions as you would see them at the bottom of the dome if you were in the planetarium. But here we can see we are looking east. It's still a little bit after 1:30 right now, so we have to move forward in time quite a bit to get to that sunrise region. Or actually, it's around 11:30 since we put time back a little bit when we wanted to see the Lynx constellation. So here I'm moving us 5 hours into the future, so we're roughly going to get to around 4:30, looking in the easterly direction. So we're getting to when you early risers are just starting to get up. And here we have some more planets. We have some sunrise planets. So right around 4:30 is when Saturn is starting to make it above your horizon. And like Sarah was saying, there's some places that don't have as much tree cover where you can see the horizon really well. This would be a good opportunity to see Saturn rise here. And Saturn isn't the only planet that's coming up. We actually have 3 planets that are in a line right before sunrise here. So to uncover another one, I'm going to push us forward an hour to 5:30. And here we have Jupiter as well. So Saturn and Jupiter. And then still right below the horizon here is Mercury. So those are the 3 sunrise planets right around now. By getting to 5:30, you can actually see that the stars are starting to fade, that the sky is getting brighter. So we're heading very close to sunrise. The final thing that I wanted to do here for this show is have us experience sunrise as we see these 3 planets come up followed by the sun. And to do so, we have some beautiful music that we're going to be able to play by the Arizona Philharmonic. And here's a little bit of sort of some background as to what that music is all about. And I'm also going to sort of put on their website as I'm doing so. So the piece that we're going to hear is called Twinkling Stars, which is part of a collection of piano pieces by local composer Henry Fleury. The collection, called Forest Rhythms, was commissioned by the Arizona Federation of Music Clubs as part of its 100th anniversary celebration. Each of the pieces in Forest Rhythms takes their inspiration from rhythms that Henry Fleury sees and hears from his backyard in Prescott. For Twinkling Stars, Henry reflects on the night walks he often takes with his wife Maria Fleury to gaze up at the vastness of Prescott's beautiful sky. What better way to celebrate the end of our Prescott Night Sky show than to have some music to our transition to sunrise by a local composer who with some very heartfelt music. And thank you again for coming by. This is going to be my last part of the talk. I'm just going to let the music play us out. We hope to see you again in the future, and happy stargazing.